when we multiply one digit by one digit, let's say 3 times 4, we can represent it as an array. So if we had 3 rows and 4 columns, so 3 times 4, we can see that that is 3 groups of 4. Or if we look this way, 4 groups of 3, which gives us 12 equal little squares. If we had 2 times, let's see how many I get here, 3, 4, 5, 2 times 6, there are 12 parts, equal parts to it. But what happens when we have a 2-digit number times a 1-digit? How can we represent that product visually? So we think about our base 10s, and we know that the big square is worth 100, the line or the stick is worth 10, and a single is worth 1. So when drawing it, we just draw a square, a line, and a dot to represent those values. So if I had, let's try 13 times 4, I'm going to set up 4 dots, and then 13 would be a 10, because if you broke it into 10 plus 3, and 3 dots. I like to draw, and maybe I'll do that in a different color, I like to draw an organizational line so that I know that I'm not going to count these dots out here as part of my answer. So what is 1 times 10? Well, it's a 10. 1 times 10 is 10, 10, 10. And then this 1 times this 1 is 1. These are all 1 times 1. So now my total, I have 40 here, 10, 20, 30, 40. And I have 3, 6, 9, 12 there. And if I add those up, then I have 52. And when done with the actual base 10 blocks, you can see here that we have 4. Oops. There was 4 here, a 10, and a 3, and it fits to make that perfect rectangle. So we have 52. Let's try one more. And if we said, let's go 52 times 3, and I'm going to go 1, 2, 3, and now I have 10, 20, 30, 40, 50, 1, 2. So I am going to change the color for organization. 10 times 1 is 10, 20, 30. These are all 10 times 1s. And now I have a 1 times 1. And now I'm going to total them up. So I have 30 here, 60, 90, 120, 150. Or for some of us that remember the arrays from the beginning, you know that 3 times 5 is 15. Oops, I forgot the 1. 150. So 3 times 5 is 15. But because we're working with tens, we know that it's 150. And then we have 6 here, so 150 plus 6.